Alrighty, sorry about that. My camera wasn't flipping, so everything was going to be backwards for you guys. So the first question we're going to go over is write the nuclear equation for the beta emitter CO60. So what is CO? CO is cobalt, cobalt-60, and 60 is going to be our atomic mass in this situation. Okay, so what we're going to be doing, let me zoom us in here a little bit. I'll get a little bit closer to the board. Okay, so we have CO60 is what we're starting with. So our first step is to write CO60 in our isotopic notation. Basically what that means is we're going to have CO and we're going to have 60. Oh, sorry, that should be a little O. We're going to have 60 at the top because 60 is our atomic mass. And then what is our atomic number of CO? That's right, it's 27. So we have cobalt 27 with an atomic mass of 60. It tells us we're going through a beta emitter. So we have a beta emission. Remember, a beta emission is E0, -1. However, what else do we have to, what's our next step? We need to make sure that our atomic mass and our atomic number is the same at the end. So we know that our atomic mass isn't changing, so we're still going to have a mass of 60, but we have a different number here. We have a -1 plus a 27. Okay, in order to get 27 and a -1, we have to have 28 on the bottom, because 28 plus a -1 gives us 27. Okay, so now, what element would we put here? We know that our bottom is 28, and what element has 28 protons? That's right, it's nickel. So our answer should look like that, or like this. Okay, because we have a beta emission, we have this here, we have 28 minus 1 gives us 27. Okay. Producing radioactive isotopes. Basically, there's a bombardment of atoms produces radioisotopes. Okay, so here we have a cobalt combining with a neutron. Here we have a manganese radioisotope with an alpha particle. Okay, so a radioactive isotope is basically an element with different masses whose nuclei are unstable and give off energy by spontaneously emitting radiation in the form of alpha, beta, and gamma rays, which we know that a radioactive isotope is. We know what radiation is. So a radioactive isotope is just an isotope of an element that does radioactive decay. So radioactive isotopes are always going to include this N. This N represents a neutron. Oh, what did I just do? I don't know what I did. Let's make this bigger again. Okay, I think we're okay. So what radioactive isotope is produced in the following bombardment of boron? So here you can see that a bombardment puts our alpha particle first. So we have boron plus an alpha particle gives us something and a neutron. This 0 should be over here. So what do we have up top here? 10 plus 4 equals 14, correct. So we should have 13 as our atomic mass at the top. And then we have 5 plus 2 at the bottom, which is 7. And what element has an atomic number of 7? Nitrogen. So you're going to get 13N7. So it's our nitrogen radioactive isotope. We know that this nitrogen is an isotope because what's the normal number or the normal mass for nitrogen? What does it say on your periodic table? It should say 14. We know this is an isotope because it's 13, which is not normal. Okay, that is all we are going to go over today. I'm going to include, so if we go to your Canvas page here, you do have a worksheet to work on. This guy right here. So what you're going to be doing is just balancing. So how did we get here? What did we put here? And what type of reaction is that? Okay. Let me know if you have questions on that. This is a little bit harder stuff that we've been doing. So definitely let me know if you have questions. Thank you.